We're recording. I'm going to do a quick walkthrough for the hydrogen bonding lab on problem 1. And I have a helper with me today, if you hear him a little bit. Hey buddy, can you be quiet for a second? Thank you. Alright, we're going to walk through question 1 on the hydrogen bonding lab. So you guys should be familiar with how to use the Lewis structure tool on mastering chemistry and drawing these out. Part A on 1 says draw the Lewis structure for this molecule. CH3, CH2O, CH3. So the way you use this as a reminder, it's probably been a minute, is you have a you select what atom you want down here. So I'm going to carbon. If it's green, it's selected. So I've selected carbon, and I'm going to put a carbon right there. You just click on the screen, and there's a carbon atom. Now we're going to attach this first carbon to 3 hydrogens. So come over here. Hey, buddy, hold on. And select single bond. Okay, and then select the hydrogen because we want to create 3 single bonds to hydrogen atoms off of this carbon. So if you hover over the carbon, your cursor will turn into a hand, and you click down and hold, and then you can drag down, and it'll create a single bond to a hydrogen once you release. So again, click down, hold, drag up, creates another bond. We want 3, so click down again. I'm going to drag over to the left and release. Now we have a CH3 group. So let's continue with the molecule. We're going to add another carbon right here. So I'm going to go back over to carbon. I want this carbon to be single bonded to my first carbon. So last time I'm going to click on this first carbon, hold down, drag over, and release. Now I've got a single bond to a carbon. To that second carbon, I'm going to attach 2 hydrogens. So click on the hydrogen again. Create your 2 single bonds, one up, one down, and see, okay, also if you do something that you didn't mean to do, like I just randomly accidentally clicked and now I have a hydrogen bond, you just erase. You can click erase and erase that, or you can click the undo button. But if you click on the eraser, you got to go back and then re-click on the select tool so that you can get back to your cursor. Okay, so we've got our CH3, CH2 group. Now I'm going to put an oxygen in, so I'm going to click on this O. I want this oxygen to be single bonded to this second carbon. So make sure you have the single bond tool again selected. So I'm going to drag over towards the right. And then I want that oxygen to be single bonded to my last carbon. So I'm going to then select my carbon atom. And I'm going to single bond this oxygen to my last carbon. And then I'm going to add 3 hydrogens onto that last carbon. So drag down to the right and up. And that's all the atoms. The only thing we're missing are lone pairs on that oxygen. So if you will come over here and select this, if you hover over, it says paired electrons. That is the tool for a lone pair. So, okay? So if it is selected, you just click and release, and it adds a lone pair. And I'm going to click again because we need 2 lone pairs on that oxygen. So this is the structure. The structure is done. So that's essentially all you need to do for part A. But let's keep going. Hold on. Did I get it right? Submit. Correct. Okay. So that's what A should look like. Now, B says determine the number of hydrogen bond donors in the molecule from part A. So remember, a donor is any hydrogen atom that is positively polarized. That's what we're calling a donor. If you go up here, we notice that all of our hydrogens are connected to carbons. They're bonded to carbons. We don't have any hydrogens that are positively polarized. So the number of donors in this molecule is just 0, okay? All right, part C says determine the number of hydrogen bond acceptors. Remember, an acceptor is a lone pair on an oxygen, nitrogen, or fluorine. And so I see in this molecule that I've got an oxygen with 2 lone pairs, which means we have 2 acceptors. So that should be the number of acceptors for that molecule. Okay, lastly, or not lastly, but part D, determine the total number of hydrogen bonds that this molecule could form with a water molecule. Well, you're going to add up parts B and C, and you'll do this for almost all of the problems. So part B is 0, part C is 2. So 0 plus 2, we could get 2 hydrogen bonds with water molecules. And again, that's how you figure out the total number of hydrogen bonds. You just add up the number of donors and the number of acceptors in the molecule, because they could each form their own individual hydrogen bond. So we could get 2 bonds with water molecules. And then E is probably the most complicated part for some of these problems. But it says show how the molecule from part A would interact or form hydrogen bonds with, did I read that right? Show how the molecule from part A would interact or form hydrogen bonds with a water molecule. Orient the donor on a water molecule, which is the hydrogen, positively polarized hydrogen, on a water molecule towards an acceptor on your molecule, and vice versa, orient an acceptor on a water molecule with a donor on your molecule. Well, we don't have any donors here, so we're just going to do the first part. And we'll do that twice, one for each lone pair on oxygen. So I'm going to redraw the structure really quick. And it doesn't have to be perfect. You can see mine's a little bit crooked. That is okay. You can adjust it if you are a perfectionist. I'm going to draw these bonds a little longer because I'm going to need some space. Okay. Add my lone pairs. Now, let's draw a water molecule where the hydrogens are just oriented towards, close to. We're not actually going to put a bond in. We're just going to draw them near the acceptors on our molecule. So I'm going to put, I just put a hydrogen first. So just want the hydrogen selected. I'm going to click really close to that lone pair. That's close enough. Now I'm going to finish my water molecule. That's 1 hydrogen. And I'm going to, oops, undo. I don't need to connect it to hydrogen, I need to connect it to oxygen, HOH. And then add my other hydrogen on. And then put the 2 lone pairs on the oxygen for the water molecule, or you probably get counted incorrect. So that's it. That's showing how, if there were to be a hydrogen bond, how that water molecule would orient itself towards your molecule. And we're going to do the same thing for this top lone pair on your molecule. So I'm going to put another hydrogen close to that other lone pair, single bond that to the oxygen on my water molecule, and add my last hydrogen for the water molecule. Then I'm going to put 2 lone pairs on that oxygen, and there's my second water molecule. And that's indicating, again, you're not putting any bonds in, you're just drawing it like that. So let's see, did it get it correct? Okay. So that's a walkthrough for part 1, or question 1. You'll do questions 2, 3, 4, and 5, I believe, are all very similar. Question 6 is just a touch different, but you actually don't draw any Lewis structures on question 6. And I hope that is helpful.